Your healthy meal is actively working against you right now, and the food has nothing to do with it. Right now, someone is sitting at their desk eating a salad, grilled chicken, leafy greens, olive oil, and their body is doing almost nothing useful with it, not because the food is wrong, because the person is stressed, and under stress, your digestive system doesn't distinguish between a kale salad and a bag of chips. It responds to the threat first and the meal second. Sometimes it doesn't respond to the meal at all. Here's the thing most nutrition conversations never touch. The food you eat is only half the equation. The other half is what your nervous system is doing while you eat it. And if it's running in emergency mode, if you're scrolling through something that raised your cortisol, if you're eating between back-to-back calls, if you're chewing through a meal while mentally rehearsing a conversation you're dreading, then your body isn't in a state that can actually process a meal. It's in a state that's preparing for something much older and much more urgent than lunch. There are two operating modes your nervous system uses. The first is parasympathetic, rest and digest, where your body allocates resources to growth, repair, and the slow, complex work of breaking down food and absorbing its nutrients. The second is sympathetic, fight or flight, where all of that gets suspended and every available resource is redirected toward survival. Blood flow, enzyme production, gut motility, hormonal signaling, all of it shifts. And here's what's important. These two states cannot run simultaneously. They are mutually exclusive. When you sit down to eat while you're stressed, you're asking your body to do two things it has literally been wired across millions of years of evolution not to do at the same time. The hormone that makes this happen is cortisol. And think about it. Cortisol is not a villain. It evolved to save your life. When your nervous system detects a threat, cortisol floods your bloodstream within seconds. It raises blood glucose immediately, pulling stored fuel out of your liver and muscles and dumping it into circulation. Because if something is chasing you, you need energy available right now, not in an hour after your small intestine finishes absorbing your lunch. The problem is that your cortisol system can't tell the difference between a predator and a project deadline. It responds to psychological stress, anticipatory anxiety, social threat, unresolved conflict with the same biochemical urgency it would use for a physical emergency. And that flood of cortisol changes everything about what happens when food enters your body. Start with appetite. Cortisol directly dysregulates ghrelin, the hormone that signals hunger, and suppresses leptin, which signals fullness. What this means practically is that your hunger goes up while your ability to feel satisfied goes down. Have you ever noticed that after a genuinely difficult day, one where you barely had time to think, let alone eat, you're ravenously hungry by evening, even if you actually ate normally throughout the day? That's not a coincidence. That's cortisol interfering with the hormonal conversation your body has with itself about hunger and satiation. Researchers studying cortisol and appetite regulation have found that even a few hours of elevated cortisol is enough to shift ghrelin levels meaningfully, and the effect compounds if the stress is chronic. But appetite dysregulation is just the beginning. What happens deeper, inside the gut itself, is where the real story lives. When your sympathetic nervous system activates, it physically overrides your vagal digestive tone. The vagus nerve is the main highway of the parasympathetic system. It runs from your brainstem down through your chest and into your abdomen and controls, among other things, the production of digestive enzymes, the coordinated muscular contractions that move food through your intestines, and the secretion of gastric acid. Under sympathetic activation, vagal tone is suppressed, your stomach slows, enzyme output drops. The same meal that would be broken down and absorbed efficiently in a calm state is now moving through a gut that's running on, as researchers in gastroenterology have put it, significantly reduced digestive capacity, right? Think about what that actually means. Two people eat the same meal. One is relaxed, unhurried, breathing normally. The other is eating between tasks, heart slightly elevated, mind somewhere else entirely. The food arriving in their guts encounters a completely different environment. One gut is churning out enzymes, absorbing nutrients through well-perfused intestinal walls, moving the bolus through efficiently. The other gut has redirected blood flow to the muscles, cut enzyme production, slowed motility. The nutritional value of the meal, the actual biological return on eating it, is meaningfully lower for the stressed person, not a little lower. Studies comparing digestion under acute sympathetic activation have found measurable reductions in nutrient absorption, particularly for fat-soluble vitamins and certain minerals. You can eat the same thing and absorb genuinely different amounts of it, depending entirely on what your nervous system is doing. And if that starts to explain something you felt but never had words for, if you've ever eaten a meal quickly between stressful tasks and still felt hollow an hour later, like you never quite ate at all, stay with this. Because what happens next in the chain is the part most people never hear about. Cortisol also does something to insulin that most people don't realize. Under normal circumstances, when glucose enters your bloodstream after a meal, insulin is released to usher that glucose into cells, muscle cells, liver cells, wherever it's needed. But cortisol raises blood glucose independently of eating by pulling stored glycogen out of your liver as emergency fuel. Over time, with repeated cortisol surges, your cells start becoming less sensitive to insulin's signal. They've been in high glucose environments so often that they begin tuning out the message. Researchers studying cortisol and metabolic function have found that chronic psychological stress is one of the fastest ways to push the body toward low-grade insulin resistance, not through diet, through nervous system state. The same carbohydrates processed by a calm, insulin-sensitive body and a chronically stressed, cortisol-flooded body are not equivalent metabolic events. One is a smooth handoff, the other is a negotiation with an uncooperative system. And here's what's interesting. Where that excess glucose ends up matters enormously. When cortisol is chronically elevated, fat storage doesn't happen evenly. It's preferentially routed to visceral adipose tissue, the fat that accumulates around your abdominal organs, deep beneath the surface. This isn't random. Visceral fat cells have a higher density of glucocorticoid receptors than subcutaneous fat. They're literally more responsive to cortisol signals. So under chronic stress, even when caloric intake is the same, the body preferentially builds fat in the most metabolically harmful location. There's a reason stressed people often gain weight specifically around the midsection, even when they're careful about what they eat. They're not eating differently. Their body's internal routing instructions have changed. Now here's where the psychological layer crashes into the biological one. Because we haven't talked yet about what cortisol does to your reward circuitry. And this is the mechanism that actually explains why stress eating feels so different from regular hunger. Cortisol upregulates dopamine receptor sensitivity in the brain's reward system, particularly in a region called the nucleus accumbens. What this means is that under stress, hyperpalatable foods, things that are high in fat, sugar, or salt, don't just taste good. They deliver a neurological signal that is amplified relative to your normal baseline. Behavioral researchers studying stress-induced craving have found that cortisol essentially recalibrates the reward threshold, making highly processed foods register as neurologically necessary in a way that plain, nutritious foods simply don't match. And I want to be very clear about something here. That's not a character failure. That's not weak willpower or poor discipline. That's your ancient threat response wiring telling your reward system that high-calorie, immediately available food is exactly what should be prioritized when danger is present. Willpower doesn't work on this, not because you lack resolve, but because you're trying to override a circuit that is deeper and older than the frontal cortex doing the overriding. Look, no, and this is one of the parts I find genuinely fascinating. The gut-brain axis adds another dimension to this entirely. The enteric nervous system, sometimes called the second brain, lines your entire gastrointestinal tract. It's a complex network of neurons that communicates bidirectionally with your central nervous system via the vagus nerve and the HPA axis, the hypothalamic, pituitary adrenal system that regulates cortisol release. When you eat chronically under stress, the gut microbiome, the community of trillions of bacteria that help regulate digestion, immunity, and even mood, is directly disrupted. Studies in psychoneuroendocrinology have found that HPA axis dysregulation alters gut microbiome composition within days of onset, not weeks. And because the gut produces roughly 90% of your body's serotonin, disruption to the microbiome isn't just a digestive problem. It feeds back upstream into mood, anxiety sensitivity, and stress reactivity. Stress eating disrupts your gut. A disrupted gut amplifies your stress response. That loop runs quietly and relentlessly until something interrupts it. There's one more mechanism that brings this together: blunted satiety signaling. Under sympathetic activation, the hormones that tell your brain you've eaten enough, cholecystokinin, peptide, why are suppressed. The brake system for hunger is offline. You can eat past the point of fullness without feeling it, not because you've stopped paying attention, but because the signal isn't being sent with normal strength. And this connects back to the interoceptive disconnection that stress produces more broadly, the way that psychological pressure narrows your awareness of your own body. When you're stressed, you're less able to feel hunger accurately, less able to feel fullness accurately, less likely to taste the food consciously, and more likely to finish a meal without registering that you've eaten. The meal is happening. The nutrition, the nourishment, the satiation, those are being compromised at every level simultaneously, which is why the solution here is not eating cleaner food under stress. It's not choosing better options while your nervous system is still in fight or flight. Stress will degrade the nutritional return of a perfect meal the same way it degrades the return on any other meal. Your body already knows exactly how to digest, absorb, regulate hunger, and build appropriate satiety signals. It does this flawlessly when your nervous system is in the right state. Your job, the one that actually changes the outcome, is not optimizing the food. It's giving the body the internal environment in which it can do what it already knows how to do. What does that actually look like? Not meditate before every meal as an abstract instruction, but something grounded in what we just covered. Even 2 or 3 minutes of slow, extended exhalation before eating demonstrably shifts the nervous system toward parasympathetic dominance. The vagus nerve is activated by prolonged exhales. This is a documented physiological mechanism, not a wellness concept. Eating away from screens, in a physically different location from where you work, interrupts the contextual cortisol cue that your environment produces. Eating with people you feel safe with lowers baseline sympathetic activation. None of these are complicated. All of them change the state your body is in when the food arrives, and that state determines almost everything else. The food matters? Of course it does. But what matters more is whether your body is in a condition to actually receive it. And every time you sit down to eat in the middle of a stress response, the answer, regardless of what's on the plate, is that it largely isn't. If that reframes something you've been blaming yourself for, good, that was the point. Tell me in the comments, what's one situation where you've noticed stress changing how you ate or how you felt after eating, even when the food itself seemed fine? I read all of these, and if this kind of breakdown is useful to you, the biology behind things you felt but couldn't explain, subscribe. That's exactly what this channel is for. There's a lot more to uncover.